The first interface that we talk to utilities about in our education sessions is the USDP Request Response Interface. USDP, the acronym is Universal Service Delivery Point. This is a identifier that the MDMR will provide back to you in a file format, after which you've sent them your service delivery point identifier. So for SDPs, utilities will have to come up with an SDP ID, and once that number has been created, you would send that into the MDMR and they would provide back to you a USDP. This is a permanent pairing that's required in your communications with the MDMR. SDP IDs are, from a utility perspective, need to be unique and never change at the utility. So those are the requirements for an SDP. Once your SDPs have been created, it's the USDP interface through which you would acquire your USDPs for any further communication between your system and the MDMR.
An SDP is a service delivery point-to-point at which delivery is metered or calculated based on the input directly from the smart meter. The MDMR uses two different identifiers for cataloging data. One, SDP ID. Two, USDP ID. What is an SDP ID, or Service Delivery Point ID? A number that an LDC assigns to a premise, unique to that LDC and should never change, can be incremental or can indicate meaning.
So the SDP ID is supplied by the LDC, and it relates to the premise. So you think about it as though it's a chunk of land or a socket, and this is you need to come up with an SDP identifier. So some CIS systems use the premise ID or a portion of their account number. Some CIS systems have come up with their own unique identifiers, starting from scratch just for this requirement. The requirement from your perspective is that the SDP has to be a unique number and can never change.
What is an USDP ID, or Universal Service Delivery Point ID? A number assigned to the MDMR to an SDP ID, unique within Ontario, randomly generated, cannot interfere with LDC by the number. A USDP ID is required to be paired with the SDP ID to uniquely identify the SDP to the MDMR.
So the USDP then is the common element to which information and services are associated in the MDMR through the use of attributes. You will provide an SDP ID and get back a USDP ID. The Universal Service Delivery Point then is a provincially unique identifier, and that's how they will associate all the attributes that you provide them for your SDP IDs.
The LDC obtains USDP ID through the USDP Request and Response Interface. The USDP Request and Response Interface processes requests from the LDC and assigns USDP ID for each SDP. ISO prefers a batch file, but an LDC can request one or multiple USDP IDs.
So the interface then to acquire USDPs is fairly simple. You send them a request for USDP IDs and they respond to it and provide you with USDP IDs. The only requirement for you then is to provide them with an SDP. If it's an SDP that's unique and has never been responded to, they will give you back a USDP ID. Okay, so once that's been done, they have a unique pairing of SDP to USDP at the MDMR. And all future transactions, like synchronization functions, will use the USDP ID as the identifier. So you can use the interface to request one or more USDP IDs at a time. The MDMR loosely, I guess, expect this to be a batch process. They never originally documented this expectation to be a batch process. Some utilities started to request them one at a time, and then they kind of made it a little bit more specific in the documentation that they kind of wanted this to be a batch process. So they kind of expect it to be a batch process at the end of each day or the start of each day. You'd ask for all your new service USDP IDs. Having said that, if you do program the interface to be a one at a time type thing, that's not going to be that big of a problem. If you do that, some utilities are doing.
The LDC sends a universal SDP ID assignment request file which contains an LDC ID that uniquely identifies the LDC, one request line for each SDP ID for which the USDP ID is requested. The request file is processed upon receipt. It's scheduled to run every 15 minutes daily. The MDMR returns the Universal SDP ID Assignment Request Summary Exception, or IR01 report, which contains a USDP assigned for each SDP and any exceptions. The IR01 report will not inform you if the CIS sent a request, but no response was received. That is, if there is an AS2 transfer problem. Therefore, Utilysys recommends that a CIS report is developed to query CIS for SDPs that have a USDP request date, but no USDP ID stored. The MDMR produces exceptions for the following conditions. The LDC is unknown to the MDMR. The file contains an LDC ID that does not match the LDC that sent the file. The SDP ID has already assigned a USDP ID. The file format or the data type is invalid. There are 4 possible transaction codes. 00, the USDP ID has been assigned successfully. 01, the LDC ID is invalid. 02, the SDP ID has already been assigned. 03, the data request is incomplete. No USDP ID. The SDP is unknown to the MDMR. The LDC must obtain USDP from the MDMR before it can initiate any activity in the MDMR for the SDP and the associated meter. USDP ID requested. The LDC has initiated a request from the USDP from the MDMR. A USDP can be requested at any time, independent of whether the service meter point is metered with a smart meter or actively consuming electricity. USDP assigned. The SDP is unknown to the MDMR, but there are no attributes associated with the SDP. SDP object created. The SDP is known by the MDMR, and a minimum set of attributes have been defined through synchronization. SDP active. Attributes that are required for the SDP to accept meter reads and produce billing quantities have been defined through synchronization. These attributes in addition to the minimum attributes required for a previous stage. These attributes are in addition to the minimum attributes required for the previous stage. SDP inactive. An SDP is inactivated when attributes are removed from the SDP record by not including the SDP in a psync file. The psync file is the only way in which an SDP can be inactivated.
So you are starting out with no USDP IDs assigned. This is how everybody would start. You would then generate your SDP IDs internally, and when it comes time to ask for them, you would send a file requesting USDP IDs for the SDP IDs in the file. So the MDMR USDP ID generator then processes this request file, and they generate USDP IDs in the USDP ID generator. Same USDP ID all the time. So this process sort of happens off to the side of the MDMR, and they randomly generate all these IDs for you, and then they pair them up to your SDPs and send them back. Okay, at that stage you have now had your SDP IDs assigned. And I mentioned that it happens sort of off to the side because the MDMR still really isn't aware of these numbers until you've sent them in a sync file. So by sending in a psync file or an isync file, you tie attributes to these IDs, and now the MDMR kind of has record of this USDP ID. That's the first time it kind of becomes used, is once you've synchronized with it. So once you've done that, sent in an isync or a psync file, the SDP object is created in the MDMR. You've now sent this minimum set of attributes, and they know a little bit about that USDP ID. If your sync file indicates electric service to the SDP, then the SDP is active. And then you just go through this cycle, possibly, go through this cycle of the SDP being active and inactive. Okay, the only way that you inactivate an SDP is by not including it in your psync file. So when we get to synchronization later, we'll talk about the difference between isync and psync files. Isync files indicate changes at the SDP. P-sync files tell the MDMR about the current state of all SDPs. So because the assumption in a P-sync file is that you're telling them the current state of all SDPs, if you don't include a USDP in your P-sync file, they inactivate it. So that's how this cycle happens.
The following MDMR functions can occur once the SDP is active: online inquiry, processing of meter reads, processing of billing quantities, reporting of historical data, manual editing of meter read data, IVR and web service API access. In the inactive state, the following MDMR functions can occur: online inquiry, reporting of historical data, manual editing of meter and read data, processing of request response billing quantities, web service API access. 4 services in the MDMR have SDP attributes. 1. The V service describes the validation, editing, and estimating rule set that is applied to meter read data. The V service describes the validation, editing, and estimating rule set that is applied to meter read data. 2. The energy purchase service describes the way in which meter read data is aggregated into billing quantities. This attribute is consistent with the framing structure attribute. 3. The data collection service is consistent with the meter AMCC type attribute. And 4. The data delivery service relates the billing quantity data from the MDMR to the LDC. This is a sample business process diagram for the USDP request process. Mike Strano walks you through the process.
So when we review these diagrams, there's a couple different things that we're going to look at. And swim lanes are one of them. What are called swim lanes, going horizontally across the page. The swim lane identifies kind of accountability for the boxes that are in it. So the boxes can be processes or steps in a process, and they're allocated to the owner of the swim lane. So we've got the sync operator starting off this process. Anytime we identify a sync operator, this is somebody at the utility that it's not really set in stone who does this job. These are kind of new jobs, and until you decide who your sync operator is and which pieces of which processes they're responsible for, it's just kind of a kind of catch-all swim lane for anything new. You got the sync operator starting off this process, determining a need for the USDP. So for the most part, once you're in your enduring process, the need for a USDP comes about because of a new service. Right? Otherwise, when you go through cutover, you're going to get all your existing USDPs and you're going to be done. And then the only time you need new ones is new services. But that is another need for USDP, right? Cutover, big thing, approach to it. A sync operator would trigger the process. The CIS system then would build a batch file. This batch file in the specs is referred to as file 1000. So this box is saying at the end of the day, build a file 1000. That end of the day is kind of a timing reference, and this will be determined by your business process. We highlight the AS2 at the utility and the MDMR. Where space allows it, we try to always put it in the file transfer because these are failure points. So when processes break down, you can always refer to the diagram and say, where are the failure points in this process, what could have gone wrong. And AS2 is certainly one of those failure points. So the file 1000 will move from your AS2 into the MDMR's AS2. They will receive that file and begin processing it. These decision blocks down here will refer to some of the business rules for this interface. So when the MDMR processes this file, one of the first pieces of logic they would use is this a valid LDC ID? So are you properly enrolled? Do you have the proper org ID in your files? If not, transaction code 01 would result. But if that's pretty easy to get through there. This will be kind of a setup thing, and once it's set up in your CIS, it should run without a problem. So you move past that logic to, has this LDC SDP ID been assigned previously? If it has, you would get transaction code 2. If it hasn't, you would get a USDP ID assigned, and MDMR would start to build what's called file 2000 to provide back to the utility. They would then move that through the AS2 client into your AS2 client, which would move into your CIS then, once received. That's a bit of a business process decision. How does that get into CIS? Is this an automated process, or is this somebody with a mouse kind of picking up that file, moving it around, processing it? Yeah, once processed by the CIS, the USDP IDs would be brought into the CIS and stored for future sync processes. The next time you use them, then is synchronization. Then we'll make reference to the report here. This is also sitting in the sync operator swim lane. IR01 is the report, and it tells about success or exception. It's important to know that when you start to acquire USDPs from NDMR, these are always permanent USDPs. There's no test USDPs really. When you're talking to the test environments, it's possible to get test USDPs, but you're not allowed to synchronize these. USDPs are copied from the production environment each night into the test environments. So you're not allowed to use the USDPs you get from the test environment because those are probably going to be taken by the production utility in the production environment.
When developing a USDP request business process for your utility, map existing business process affected. 2. Determine gaps in existing processes, such as: do you have a unique identifier? How will USDP IDs be acquired for existing SDP IDs? Who will manage the IR01 reports and exceptions? Who will act as sync operator? 3. Determine new business processes to be developed.
Once you've gone through your formal testing stages, you'll be given permission to cut over into the production MDMR. While we're still in education session 1 and talking predominantly about the USDP request response interface, at the end of the session we'd like to talk about a couple of processes that will come into play later on, but we feel that it's important to start thinking about them early. So the cutover process, one of the things that we really stress during that business process discussion is the idea of web presentment of information. Once you get cut over into the NDMR, you're going to be busy with many other functions, and so we've seen some utilities perhaps leave their consideration around web tools a little bit too late and end up getting into a bit of a hurry to try and pull these tools together so that when they begin billing on time of use, they can provide the education tools that they feel they want to provide. So one of the things you may want to add into your project plan early is the development of an RFP, should that be required for your utility, for a web tool. So these are, along with the web tool, are educational pamphlets and sort of mailings perhaps that you'll want to provide to your customer base. So these things should all be considered fairly early on, as they will require time to develop the material and then have it prepared in time for when you begin your cutover to time of use. Web tools are, I think, one of the most important things that we talk about in our cutover strategy during education session 1 is just a reminder to think about these things. The other things that we stress during that cutover business process document is the unit testing requirements. You want to think about your business processes in advance, which is what we're doing now. We're starting to get you moving on your documentation of business process so that you can properly test these functions. And then finally, the last thing that we talk about in this document is the actual synchronization at the time of cutover, and some of your V service codes and synchronization functions that can impact how you cut over. One consideration, for example, is your AMI data. ISO NDMR does not like it when utilities perhaps synchronize small numbers of SDPs but then submit AMI data for their entire population. So this is not an easy process to work around, so you should think about it early, and for the most part I think utilities end up concluding that perhaps it's just easiest to synchronize all their SDPs in the first few days of cutover. So those are some of the things that we talked about in our preparation for cutover strategy.
It is important to note that the MDMR does not functionally tie flowing meters to the billing process. You could flow meter data from the MDMR and not bill for months, even years, before starting to bill from the MDMR. Your tow schedule is not dependent on your schedule to migrate meters to the MDMR. Take advantage of this opportunity to tune your AMI network. A properly tuned AMI network should collect between 98 and 99% of data. Develop your MDMR business processes, which once cut over, you can use for testing. Become familiar with the MDMR reports. Become familiar with the service request process to resolve NVE intervals. Work on ODS functions, such as backfill of data, Prepare customer educational material. Develop web presentment tools. An RFP may be required.
The MDMR bills on midnight reads for the most part in today's environment. So all of your usage data will be framed on a 24-hour basis from midnight to midnight. Because your existing business process to bill involves manual meter readers that are walking around through the day, not acquiring midnight reads, there is a transition that you need to go through to move your billing process into a midnight read billing process before you begin acquiring your bill quantities from the MDMR. So there's a transition there that should be considered. This is made fairly easy through the use of interfaces such as your DCI/DCO process, which could be provided to another vendor such as an ODS provider to provide back to you midnight readings to accommodate this need. So if you're not going to utilize an ODS and don't have such things as a DCI/DCO interface, which most of the systems use today, then we should talk further about this process to make sure that you haven't put yourselves at risk for duplicating billed quantities to your customers, or having to move through a stage where you lose consumption and are not able to bill for it. So this midnight read process is not necessarily a difficult one, but should be considered well in advance.
This is a sample business process diagram for the midnight read process. Mike Strano walks you through the process.
This business process diagram is kind of generically illustrating for you just a request file, and you just stick the name DCI/DCO in there if you're going to use an MVRS file format. Put that through your AS2 or some other file transfer protocol to your ODS. We've got this labeled as AMCC/ODS. In the beginning, Census would sort of do this for you. They may charge you for it, but if you're only doing it for a month or two, might not be a large cost there, but and if that's the way you have to do it to accommodate this need, it's probably money well spent. But basically, you're going to provide a file to the ODS where they will go and try and find the closest midnight register read to your billing date, and put that into a response file, send it back to you, and you will move through the billing process that you're in today, register read billing.
This concludes the USDP interface module. In session 2, Utilysys walks you through the next MDMR process, synchronization.